two charges each equal to q are kept at x equals to minus a and x equals to a on the y-axis. A particle of mass m, charge q naught equals to q by 2, is placed at the origin. If charge q naught is given a small displacement y much smaller than a along the y-axis, net force acting on the particle is proportional to. Alright, so here basically we have been given that this is a line, okay, x-axis, and on that this is our y-axis here. Now two charged particles that are kept at this position, and let's say at this position, two different positions. So one charged particle is kept here, another charged particle is kept here. So one particle is kept here, that is q. Another particle is also kept here, that is again q. This distance is given to us, that is a from here, and this is also distance a from here. Now there is a third charged particle which is q naught, that is kept on it, and which is at a distance of y on the y-axis, and it is given that the condition is y is much lesser than a. We have to find that the force acting on this charge q naught is of function y minus y, 1 by y, or minus of 1 by y. So in this scenario, what will be our approach? So first of all, we will try to find the force on them using Coulomb's law. So because of this one, I can say that the force will be in this direction, and because of this one, the force will be in this direction. And I can say that this charge and this charge have equal magnitude, and this charge is at same separation from this one and this one. So this angle and this angle are equal, and this force and this force are equal, and the resultant of these two forces, I can say that it will go along this line. This will be the resultant of these two forces. So if I try to find the resultant of these two forces, so first of all I need to know the angle that is between them. So let's say I am saying that this angle is theta, this angle will be also theta here. So this is theta and this is theta. Now this force is F, this force is also F. So resultant of these two forces, if I calculate, then F net is how much? F net will be 2F times cos of theta. Now if I write the value of F, F is what? F is basically, if I calculate F here, then F I will be writing K Q times Q naught divided by R square. Now what is R square? So this is R, okay, and R I can write is nothing but R is basically A by sine theta. Okay, R is basically A by sine theta. So this will become 2F. F I can write here as K Q naught divided by A square by sine square theta, and then this is cos theta. And if I simplify this, then this will become 2K Q naught by A square sine theta. It will be cos theta into sine square theta, like this way. Okay, now I can say that if I substitute the value 2k q naught by a square, if I substitute the value of cos theta, so cos theta is how much? Cos theta is y by under root of a square plus y square, and sine theta is basically a square, sine square theta, a square by a square plus y square. So you can see that a square and a square will cancel here, and we will have a term 2k q naught. Okay, then this is y divided by a square plus y square raised to the power 3 by 2. Now for y much lesser than a, I can say a square plus y square raised to the power 3 by 2 will be equals to a q. So the force will come out to be 2k q naught. Okay, this is y by aq. So I will say that the force is proportional to, here I will say force is proportional to y. So correct option is option 1 here.